Well, right?
Good morning, everybody. All right, so let's do a little bit of review about what we've been talking about. What have we been talking about? Sydney?
Volume.
We've been talking about volume. And when I left you last, I believe it was Friday, we worked on two formulas for volume, right? Who can tell me one of them? Who can tell me one formula? Tyler?
Base times height.
Base times height. And what's the other one? Connor?
Length times width times height.
Length times width times height. And what is base times height? What is base? What is the base? Jack?
Length times width.
Right. So base is length times width. So we have two different ways to figure out our volume. Whatever you're more comfortable with, we talked about that. If finding the base and then going by the height is the way you like it, great. If length times width times height is the way you like it, we can do it that way. If this was centimeters, what's our unit? What's our unit going to look like? Two different ways to write it. Sydney, give me one.
Cubic inches.
So cubic, like a CU.
And 7 inches.
Yep, we'll do centimeters. And what's another way we can write it? JJ?
Centimeters and then 3.
Centimeters and then a 3. So all of our problems, if we're not doing it in unit cubes, are going to have one of these two, right? Okay, so I gave you some homework on Friday. It was two-sided. We're just going to go over the front side first, and then pass them forward, and then we're going to move on to our next lesson. And our next lesson is going to be comparing volumes of different items. Say you're packing and you need to know what size box, or items along that line. So let's review the homework, make sure that we're on track, and then we will move on to the lesson. So we're going to do finding volume of rectangular prisms. We're doing this side. So everybody should have this out. So give me your formula or your number model, and then give me your answer. Remember to include your units. So number 1, what did we get for number 1? Mason? Centimeter cube. What was your number model?
2 times 9 times 7.
2 times 9 times 7. And what did we talked about the number model. If your number model wasn't 2 times 9 times 7, would you still get the same answer?
Oh.
So if you had a number model of 7 times 9 times 2, that was okay, right? Okay. Number 2, what do we get for number 2? Timmy?
80 centimeters cubed.
80 centimeters cubed. How are we doing so far?
Good.
Good? Number 3. What do we get for number 3? Jada, is your hand up?
Yeah.
What do you got?
120 cubic centimeters.
120 cubic centimeters. Did everybody get 120? Number 4. Connor W., what do you got for number 4?
200 centimeters cubed.
200 centimeters cubed. Number 5. Ashley?
90 cubic centimeters.
90 cubic centimeters. Good. Number 6. Who's got number 6 for me? Who's got number 6 for me? Anna, you're number 6?
Yeah, I just wanted to include.
Okay, that's fine.
Number 640 centimeters cubed.
Number 640 centimeters cubed. Can you glance down at that model and take a guess at what it?
Yeah, you can do 5 times 4 times 6.
5 times 4 times 7. Perfect. All right, number 7. Jack?
96 centimeters cubed.
96 centimeters cubed. Number 8. Number 8. Connor? Slipka?
192 centimeters.
192. 9. Cindy, what do you get for 9?
168 centimeters cubed.
168. We are in good shape. Number 10. JJ?
45 centimeters cubed.
45 centimeters cubed. How'd you guys do? Good. Anybody have any questions on how we did those? No? All right, pass them forward. And if the person in the front row can just collect them right at the front, I'll take them and I'll look over the back. And then I would like you to open up your Encore book. You're going to go to page 183. So, like I said, page 183, problem solving. It's lesson 92. Everybody on 183, lesson 92? So, problem solving. Word problems. We're going to compare volumes. And I can think of one right off the bat. Miss Shear has 2 aquariums in the back of the room. She's got a big one. She's got a little one. We wanted to compare the volumes of those. What would we do? How would we compare the volumes of those? Jack, what do you think?
Estimate the volume of each one.
So figure out the volumes of each one and then compare them. We can figure out which one's bigger. We can probably look at them and take a guess, but we still don't know what the volumes are. What if we wanted to know how much the bigger aquarium was than the smaller one? Then we'd have to figure both volumes and then do another problem. So these might be multi-step problems. And one of the ways that we can figure this out is by making a chart. And that's what they do on page 183. So the first question, read the question at the top for me, above the box. D?
A company makes aquariums that come in 3 sizes of rectangular prisms. The length of each aquarium is 3 times its width and depth. The depths of the aquariums are 1 foot, 2 feet, and 3 feet. What is the volume of each aquarium?
All right. So perfect that I used the aquarium the aquariums at the back. Okay. So on that page in the box, we have read the problem and solve the problem. So I'm going to make a
Excuse the interruption, just to let you know that the last bus has arrived. You will be getting students in your room. I'm hoping that you still have been holding your attendance. Thank you.
Okay, so on this chart, what does it have for the 3 labels at the top? What are the 3 labels at the top that we're going to use? Vita?
Length, width, depth or height, and volume.
Right. Okay. So length with height. So we're going to make a chart. We're going to compare these 3 aquariums. So it is filled in for you, but let's go step by step. So what do we need to find? What are we finding? Mason, what are we finding?
The volume of each aquarium.
Right, so we're finding out the volume of each aquarium. And we know our formulas. And it tells us that the depths are what? The depths of each aquarium are what? Brianna?
1, 2, and 3.
1, 2. So we know the depths are 1, 2, and 3. And it says that the length is 3 times the width and the depth. So we know the width, if we know it says height, but it's depth. What does it tell us the width is going to be? What does the problem already give us? What does the problem give us? Timmy?
It says 1, 2, and
Right, so the width is the same. And so what's the length going to be? It tells us that the length is 3 times the width and the depth. So what is this going to make this length? Madison?
3,
3,
6, and 9.
3, 6, and 9. So we just filled in our table. And now we're just going to figure out the volume, and we're going to figure out which one's the biggest. So what's the volume of the first aquarium? Sydney?
3.
3. What's our units on this? Sydney?
E.
Feet. Feet squared?
Cubic feet.
Cubic feet. All right, what's our volume on our second one? Violet?
24.
24. And what's our volume on our last one? D?
81.
81. So obviously, which one has the biggest volume? Sydney?
The 9.
Right, the one with the length of 9. Good. So we can use this table. We could use this table to figure out the volume of the aquariums in the back. So whenever you're trying to compare volume, say you're packing, say you're moving, and you have a couple different boxes, you can figure out the volume of the boxes, because maybe they're different shapes, and you don't know which one's going to give you the most volume. We can use a table. So let's move on to the first question, and we're going to make a table. We're going to make a table for that. So can we keep the headings? You think we're going to use the same things? Yeah. So who wants to read the problem for me? Who wants to read? Tyler?
Jamie needs a bin for her school supplies. A blue bin has a length of 12 inches, a width of 5 inches, and a height of 4 inches. A green bin has a length of 10 inches, a width of 6 inches, and a height of 5 inches. What is the volume of the bin with the greatest volume?
Okay, so what do we need to, so it's asking us what? What's the question? What are we trying to find out? JJ?
What is the volume of the bin with the greatest volume?
So we want to find out which bin is the bigger one. But we don't know the volume of either one. So we need to find out the volume of both and then compare, right? Okay, so what are the dimensions? What are the dimensions of the blue bin? Brianna?
12, 5, and 4.
So 12, 5, and 4. What are the dimensions of the green bin? Ashley?
10, 6, and 5.
10, 6, and 5. So looking at this, we can't really tell right off the bat, just looking at those measurements, right? We don't know which one's bigger. So, independently, figure out the volume of the blue bin, figure out the volume of the green bin, and raise your hand when you have them, and we'll compare them. So take a minute. If you need to write it down or write out the formula, our number model is pretty much right here. All right, so who has the volume of the blue bin? Who has the volume? What, Julia? Connor? Blue bin, what's the volume?
240.
240. So we did what? 12 times 5 times 4? Okay. 240.
Centimeters. No, inches.
Is that what everybody got? Yes? Who has the volume of the green bin? Jack?
300 inches cubed.
300 inches cubed. Did everybody get 300 inches cubed? Which one's bigger? D? Green. That's pretty easy to tell. But would you have been able to look at this without the volume and know? No, not right away. You'd have to maybe do some mental calculations. So the green bin is bigger because it has a volume of 300 inches cubed. So when we move on to number 2, right next to it, it's the same, we're building off the same question, but it's changing the blue bin. It's changing the size of the blue bin. So let's add this. There's no need to make a new table. And use the data from this one. What are the dimensions of the new blue bin? Connor W.
5. The length is 5. The width is 5. And the height is
12. Okay. So our second blue bin is 5 by 5 by 12. So let's figure out the volume. When you have a volume, raise your hand. Give everybody a minute to get an answer. Georgie, you working on it? Yeah? You want to write anything down here so we know what you're doing? So what's the volume of the second bin? 9? 300. All right, so now we know the volume of the second bin. What's the question it's asking us? What's the question that it asked us? Sydney?
Would one bin have a greater volume than the other?
So now that we got a second blue bin, does it have a greater volume than green? No. Why? Jack?
Because they're both 300.
They're both 300 inches cubed. So they both have the same volume. Does that make sense to you? Comparing volumes. So we could, if we wanted to, I could hand you out some boxes and we could compare the volumes, right? Because do you know what the volume of this is? Or the volume of this, and which one's bigger? We don't, do we? But we could take the measurements, we could make a table, and we could determine which one's bigger. You guys want to do it? No? Let's do it. All right. So let's just take a guess. This is just for fun. What's going to be bigger, lasagna or cereal? Jack, what do you think?
lasagna.
You think lasagna is going to be bigger? Anybody else? I got one for lasagna. Brianna, what do you think?
I think the cereal is
You think cereal? All right, so we got one for cereal. Why? What makes you think the cereal might be bigger?
Well, it has bigger size, kind of. Well, I mean, one is like more skinnier than the other.
So this one's skinnier.
Yeah.
Okay.
So,
Anything else? Putting them side by side like this, does that change your mind? Tyler?
lasagna.
You think lasagna's gonna be bigger? All right, so we got a couple votes for lasagna. All right, so I need 2 volunteers. Georgie, why don't you come up? Jada, come up. I see some rulers over here. So Georgie, you're on lasagna. Jada, you're on cereal. In inches, let's figure it out. All right, so Georgie, measure the lasagna, round it to the nearest inch. No, let's measure it closed. The box would be closed. And let's do the nearest inch. So if it's just over 10 and a half, we're going to go to what? 11. So this is a lasagna box. All right, so what do you have for your length, Jordy? You're going to round to 10. Okay, what's your width? 4. Now what's your height? Right, now remember you just measured this distance when it was laying down. So your height in the position that the box is in is going to be here. And Judy, you can be doing the same if you think you can remember them. 3. Okay. So Jada, what do you have for the cereal?
For the height, I'm going to use it
Okay.
at 11.
11.
For the width, I have 8.
8.
And I will try this part.
Yep.
For this one, about 2.
2. Okay. So do we have everything we need to figure out the volume of those boxes? Seeing the measurements, does anyone want to change their guess? Jack wants to change his guess?
I think it's cereal.
Now you think it's cereal? All right, so let's figure it out. All right, thanks, girls. So what's the volume of the lasagna? What's the volume of the lasagna? We're going to do 10 times 4 times 3. And we did inches, right? So we know it's going to be inches. Let's put our units here. So what do we have for a volume of the lasagna box? Connor S?
120.
120. Okay. What about the cereal box? What do we get for the cereal box? Ashley, you got the cereal box?
176.
176 inches cubed. So, excuse me, which box holds more? Which box holds more? Violet?
The cereal.
The cereal. So we couldn't tell that by just looking at these. But once we measured and we made a chart, we could figure it out. Do you find the chart helpful? Yeah? Keeps your information organized, right? Okay. You want to try any on your own or you want to do another one? What do you think? Jada, what do you want to do?
We do another one.
You want to do another one together? Okay. So let's see. So page 184. Let's do, we're not going to start at the top. I think we're going to start with number 4. This is most like what we've been working on. So, again, we're going to make a chart, right? Should we keep length, width, and height up there? And the volume? Should we leave the chart just the way it is? Yep, okay. So, Georgie, why don't you read number 4 out loud.
Jeff put a small box that is 12 inches long, 8 inches wide, and 4 inches tall, and a second box that is 20 inches long, 15 inches wide, and 9 inches high. How much space is left in the larger box?
Okay. So, how many boxes do we have? Brianna?
2.
2 boxes. So we have box number 1 and we have box number 2. And do we have the dimensions of both of those boxes? Okay, so what's the dimensions of box number 1? Julia, what's the dimensions of box number 1? Yep. Okay, so we're on number 4. So the dimensions would be the measurements. So it tells us how big the box is. A small box. So why don't you read off the dimensions or the measurements of the small box that the word problem gives us.
12 inches long, 8 inches wide, and 4 inches.
All right, good. So our first one's 12 by 8 by 4. What's the dimensions of box number 2? Sydney?
20 inches long, 15 inches wide, and 9 inches high.
And 9 inches high. If one box was inches and one box was centimeters, could we compare them? Would we be comparing them equally? Connie, you're shaking your head. Yes, we could, or no, we couldn't. Why? It's not the same measurement. We're comparing inches to centimeters. While you could do some fancy calculations to figure it out, for our purposes, we want to make sure that all of our units are the same. So let's figure out the volume of 1 and 2. Does anyone have it? So looking for the volume of number 1. When you have it, raise your hand. So what we're doing, right here, see here, we've categorized all of our information into how we need it for our formula, length width height, and now you do the computation. When you think you have the volume of number 1, Violet, is that a raised hand? Yeah, what do you got?
384.
384. So you did 12 times 8 times 4. Did you do any of that in your head before you wrote it down? No, you wrote it all down. Did anyone do one of the computations, Julia?
I did 12 times 4.
You did 12 times 4, you knew right off the bat, and then you only had to write 1 down. Good. So if you can shorten your work by doing that, you should do so. Does anyone have the volume of number 2? D?
2,700.
2,700. Anyone get anything else? So does this give us the answer to our problem? It doesn't, does it? What's the question that it's asking, Jack? What does it want to know?
How much room is left in between the two boxes?
How much room is left? So do you know what that means? How much room is left? If this is box number 1, and this is box number 2, and we put it inside, does it fill up the entire box? Is there extra space? That's what it wants to know. The question is asking us how much extra space. So if you look in there, you can see that doesn't fill it up. So it wants us to find out what the difference, how much extra space. That could be figured out to, how many more boxes could we put in there? So what's going to be our number model for finding the difference? Violet?
2,700 minus 384.
2,700 minus 384. You got an answer? See, what do you got?
2,316.
2,316. Does anyone want to see us do the math? The borrowing? Or are you guys comfortable? Are you comfortable with that? Yeah. Did anybody do the counting up method? No? You just did straight trade first? Yes? Okay. So our answer is 2,000. have time for one more. Let's see. You know, let's work together on number 1. And what I want you to do is take out your sugar cubes. It's tricky. Take out your sugar cubes. You're going to have to work together on this. So maybe what we can do is have these 4 work together, those 4 work together. We'll take these 5 working together, and those 4 working together. And I'll read the question to you. Amina wants to make a mold for a candle. She wants the shape of the candle to be a rectangular prism. Rectangular prism is any shape like this, right? She wants the volume to be exactly 28 cubic centimeters. How many different molds can she make? So what I want you to do is I want you to make me a shape that is 28 cubic centimeters, and then I want you to give me the dimensions of it. So if it's going to be a volume of 28 cubic centimeters, let's call these centimeters. How many of these are you going to use? I know. How many of these are we going to use? Timmy?
28.
28. So I want you to work together because I know you don't have 28. So I know you don't have 28 total. So build something, build a shape with 28, and then I want you to tell me what your dimensions are. So we're gonna pool our cubes. So you just need one shape. So we want to have 28. So guys, what else? So work together. So what we're going to do.
Okay, so what could you
So we
combine?
have 28. So how many do you have? You have 17. So you need how many more? 2, 4, 6, 8, 10, 11. So with just those, make a shape. Now remember, it can be like this. It can be like this. It can be like that. But it can't be like this.
One plate together.
That's like a chair. So now remember, it has to be like a cube or a rectangular. It can't be a shape, which we're going to learn about tomorrow. It can't be a composed figure. A composed figure is a shape like this, where it has 2 different parts to it. It needs to be flat. Flat meaning equal. So think of your Rubik's Cube. So how are you guys doing? Are the girls working together? Do you guys want to just, the 3 of you work together? You want to do that?
So how many have in plate?
Perfect. So build a shape. And if you think you can come up with more than one shape, then that's fine. And for the purposes of this word problem, it's a mold for a candle. Okay. How are you guys doing? Do you have one? Okay, perfect. You guys got one? I like yours. You guys got one. All right, so leave these 3 groups, leave them where they are because we have 3, you guys have 3 different examples. So this is perfect. You guys almost there?
So if we did 1, 2, 14. Or if you did this 4, and then we're just kept going.
Can only use 28. Alright, so how are we doing? Yep, remember, you can't have the extra layer. Yep.
So this would be like a solid, right? The one that is.
So now is that 28? So there's 6. Oh, you sure? Recount that, Jada. I think you have more than 28.
All of your 28 pieces.
All right, so Julia and Anna, you have a shape? Boys, do you have a shape? Okay. And you guys have a shape, right? No one moved their shapes? That's all right. So do you remember what it looked like? Do you remember your measurements? Okay.
So that's not going to, right? They all have to be used. Because otherwise you're going to have volume of 28, right?
So remember, if you're having trouble, think back to the formula and think back to what you need, what 3 numbers you can multiply together to get 28.
Kind of reverse. You know the answer.
What 3 numbers can you multiply together to get 28?
Could be the 3 numbers, length, base, or the length, width, and
Hold on, hold that thought, Cindy.
to use to get 28.
That's what we need, that's what you need to find the volumes. So let's come back together as a group and let's see if the other students sharing their ideas can help you guys, okay? So I know these guys had it. So give me one of the measurements. Jack, what did you have?
7, 4, and 1.
So you had something that was 7 by 4 by 1. Does that equal 28? Volume of 28? On units. Okay, what was another shape that you had over here? Dee, what did you have?
14 times 2 times 1.
14 times 2 times 1. Does that give us 28?
Yeah.
Yep. Did you guys have another one? No? Mason, do you have one?
We did 7 times 2 times 2.
7 times 2 times 2. Does that equal 28? Right. So if you weren't sure, the cubes could help you through trial and error of building it, right? But if you weren't sure, you could always look and say, oh, 28. What do I know are multiples of 28? You could go straight to 7 times 4, and then times 1 is 28. Or you could do some variation of that. And for this problem, that's what she was doing. She was trying to figure out how many different shapes she could make a mold for a candle. And so some of these, if you had a 7 by 2 by 2, 7 by 2 by 2, you can hold it like this. I know this isn't 7 by 2 by 2. And the wick could come out here. Or you could turn it, and the wick could come out here. The same with, think of these. You could have it, the wick could come out here. The wick could come out here, or the wick could come out here. So for the purposes of the candle, we could rotate some of these around. 14 by 2 by 1. Because we talked about the volume doesn't change based on how we stand this up. Okay? So do you see that how we can almost work backwards? Filling in that chart, we know our volume, and so then we work backwards. And if we said, okay, well, if our height is, somebody might have gone and said, well, if our height is 1 and our width is 2, it has to be 14. There's no other way that we could get volume from that. Does that make sense? Okay. So what we're going to do, how do you guys feel about word problems? Okay? Jack's giving me a thumbs up. Tyler's giving me a thumbs up. We need to make sure when you're doing a word problem, you need to figure out what you're looking for and then find the data and the information that it gives you. And for this purpose, we put it into a table and it helps us to organize our information, come up with our answers, and then figure out what numbers we need to compare. So a lot of these are multi-step problems. So for tonight's homework, I'm going to pass it out, but what we're going to do is we're going to find the volume of a rectangular prism at your house. So we talked about this the other day. What kind of rectangular prisms? Because you might think rectangular prisms at my house, I've got none. I have 0 rectangular prisms at my house. What? We already know 3. I bet you have cereal. Might have butter, maybe some pasta. What else can you use, Sydney?
A picture frame.
A picture frame. Yep, you could use a picture frame.
Your TV.
You might be able to use your TV if you sort of, chop off the back and don't just take the length and the width and the height. Yep. What else, Jada?
You can use this book.
You could use your Encore book. Jack?
A Lego box.
You could use a Lego box. You could use a shoe box. Any food container could work. Any book that you might have. So you should be able to find some rectangular prisms at home. And if you don't think you can, look around the room. There's a filing cabinet. This is a rectangular prism. You could write that down. So what I want you to do is you're going to pick 4 items at your house. So you might have butter box, cereal box, book, TV. And then I want you to estimate which has the biggest volume before you do any measuring. Okay? So I want you to take a guess. Yeah, I think the filing cabinet is going to have a bigger volume than the butter box. But I'm not sure if the pasta is going to have a bigger volume than the cereal box. So that's what we want you to do. Any 4 items that you want, then I want you to take a guess. Then I want you to measure them, filling in the length, width, and the height. Calculate the volume. Don't forget your units. And then just rank them based on what on the data that you have once you calculated all your volumes. Does that make sense? Do you have any questions? Jack?
By ranking them, do we just write them in order?
Yeah, so let's do, so on here, estimated order from smallest to greatest. So whatever you think is smallest is going to have a number of 1. Whatever you think is going to have the biggest is going to have a volume of 4, a ranking of 4. If you do it the opposite way, it's fine. Just be able to know which one is the greatest and which one. And then just look and see how you did. Because sometimes volume can be deceiving. We found that out when we measured lasagna and cereal. We weren't quite sure. Okay? Does that make sense to everybody? All right. So I'll hand these out. So this is for homework. And then tomorrow I will be back and we're going to talk about composed figures. Does anyone know what a composed figure is? Brianna?
It's kind of like 2 different, figures combined in one.
So two different figures. So a composed figure is right. It's 2 rectangular prisms put together. So tomorrow we'll work on figuring out the volume of a figure that looks like this. So this is a couple different calculations. Something like this is easy when we already figured out the volume. So we'll have to combine them. So we'll work on that tomorrow. So this is for homework. So put that where you put your homework. Put your sugar cubes back in your bag, because we will definitely be using sugar cubes tomorrow to build some composed figures. And we'll give it back to Miss Shear. Awesome.